Hopefully everybody brought some Dramamine here because we went full Prezi, so I apologize in advance. So, hi. I'm Mike McLane.
And I'm Joe Crim.
Cool. Let's fix this. Hello. Hi, can you hear us now? Fantastic. All right, so anyway, I'm Mike McLane.
And I'm Joe Crim.
Cool. And today, we'd like to talk about web performance observability. Ooh, So in this talk, we're going to be going over some background on what we've done, how we've got here, and kind of go over some of our web performance stack that seems to work well for us. Maybe it'll work well for you, maybe it won't. We'll find out. So Joe and I both work in the field of performance engineering for GoDaddy's hosting products. And before we dive in, I just want to say that while we're both employees of GoDaddy, any information shared here is from us as individuals and does not necessarily reflect the views of our employer. So, yep, sorry. Hello. Good? Better? All right. Why we're here, what is it that we do? So we go out and understand first how people use web hosting. We measure how our architecture performs and then decide if the performance is satisfactory or not. If not, we then make it better by removing bottlenecks. The first part of this journey requires that we understand what our customer use cases are. We have to understand how our architecture performs and then decide if the performance is satisfactory or not. If not, we make it better by removing those bottlenecks. So the first part, I said that, sorry. So one of the things we do is we take a look and say, okay, how are people using hosting? Which can be, setting up blogs about, somebody's favorite movie or, PHP RSS feeds about the latest celebrity gossip news, whatever. We find that it's really important first to understand what common application use cases there are. It's very important to actually know your customer and validate your assumptions. So early on, we hypothesized that WordPress is a fairly common application, and it might make a good control application for performance measurement. So in analyzing our customer usage patterns, we found that, sure enough, a lot of people do use WordPress, which, if you've never heard of it, is a popular PHP content management system. We also found that a significant percent of our customers were using that to define their digital selves. So we decided that using WordPress as the main benchmark model for testing our architecture was the way to go. We also found that in that analysis, our own data aligned pretty well with some public statistic sources, such as w3text.com. In their April 2014 analysis of the top 10 million Alexa measured websites, nearly 40% of those sites use some form of content management system. Of those sites using a CMS, WordPress actually powers 60% of those, so it's a pretty big chunk. With defining how a large segment of our customers use hosting as a platform, we decided that, yes, this is the thing that we can measure that will actually make sense. So let's talk about performance. So why does site performance matter, right? So understanding the page serve speed of a website is absolutely a critical piece to ensuring that you have happy customers that don't just use your service, but love your service, right? So if you're doing awesome in this area, users of your service don't even need to think about it. If you're not doing so great in this area, customers having a bad time are going to be vocal about it. 30-second page load times, 20-second page load times, nobody has time to wait for that, right? And so if people are having a bad time, they're going to take to the Facey Spaces and the Twitter books and all that kind of stuff to let people know they had a bad time. So also another thing is handheld devices, right? Like phones, tablets, etc., are no longer a niche market. Mobile is absolutely a first-class interface to the web, surpassing desktop browsing in many cases. So does anyone play video games? Any gamers out there? Okay, sweet. So sometimes you're playing a video game, right? And you're doing awesome, cool things, and you get to a loading screen, and it totally interrupts your play. And you're like, wow, I really wish this loading screen would take even longer, right? No, nobody wants that. right? Bad times. Hitting basically a web page that takes a really long time to load is a similar experience. Nobody wants to wait, right? So, sorry. So, unsatisfactory performance has a direct effect on your revenue too. Large search engines, such as ones that rhyme with, say, Schmoogle, when calculating search results, will take into account the speed at which your page loads. So if you're trying to share your totally awesome widgets with the world and you're buried on page 5 or 6 of the search results, you're totally missing out on a lot of potential revenue. With the ability to reliably measure performance over time, we've been able to study and then answer questions such as, how does the site load performance of web pages served via remote storage compare with that with sites that are loaded from local disk? We've been able to take on lots of criteria in this area and start answering questions about using a stack that we call WebRocket. So what problems are we trying to solve with WebRocket? Well, with WebRocket, the main question we're trying to answer is, how long do web pages take to load in a real browser? We know we want the measurement stack to be scalable, right? The engine has to work as well as it does for one website as it does for 5,000 websites. In one of our installations, we're pulling over 3,500 websites within a 5-minute window. And that seems to be going pretty well. We also know we want this measurement stack to be reliable, right? WebRocket has to be legit. The data collected with it has to be real, relating back to what a real human would experience. We also want this tool to be accessible, right? We don't want people to go to the WebRocket dashboard, look at it, and not understand what they're looking at. So, what is WebRocket? In a nutshell, WebRocket uses a headless web browser to measure how fast web pages load relative to what a real human might experience. WebRocket also captures interesting metrics about that page load, including the time it takes for the first byte of data to hit the web browser, or the number of assets in the page for a page loaded with a web browser. It can also report the time measured from the point the request leaves the web browser to the time the first CSS or JPEG files delivered back. With full details enabled, WebRocket can record about 100 different bean counters about the page load experience. We then take that data and draw some interesting time series graphs using that data. So why didn't we go with a commercial solution here? Well, we did take a look at some options out there, and we found that some commercial offerings were simply too expensive for our scale. In order to pull the sites that we wanted to pull, it would have meant having to pay hundreds, if not thousands of dollars. We also found that while some commercial options had okay ways to get the collected data, others provided not so great access to the data. Or data resolution was so heavily summarized for a time period, it was just unusable. So internally, we had a strong need to align the performance time series data with activity time series data. For both operational and architectural reasons, we do a lot of dashboards internally with Graphite, so having the ability to feed raw data into Graphite's great. We also had a product need to make the polling source of sites a positional item. In this, we wanted to be able to pull some web pages from both an internal source as well as an external source. And unfortunately, not all commercial providers allowed this ability or did so at a fairly significant cost. We also looked at some open source projects that encompassed our ideals, and we didn't really find one that tied all the pieces together. We took a look at Casper.js, Selenium, Water, Ghost.py, which are all really fantastic projects. But unfortunately, none of them really kind of tied everything together or introduced some compatibility challenges to maintain across different OS distributions. So we made a decision early on that we were going to open source our solution. We thought, well, surely we can't be the only people that are trying to solve this problem or solve these problems. We also felt strongly that the open source community has provided so many wonderful tools and libraries that we should make a conscious effort to make sure we give back here. So when we started development, we decided to time box the story to about a week. With our leadership's blessing, we decided that we would put the other important business priorities on hold and spend no more than a week on this. If we couldn't get a prototype up within about a week, and we couldn't prove that this method of page load measurement was directly comparable to how a real web browser operates, then it wasn't worth further exploration at this time, and we'd have to come up with another solution. So in about 3 days, we had a working prototype, and after several tests from various perspectives, we proved that this programmatic method for measuring web page load was actually spot on with how a web browser operates. So One of the key pieces is the web page polling engine. Here we went with Phantom and a wrapper script around that. Phantom.js is a headless WebKit JavaScript API. That's a lot to say. Some brief history on WebKit. So WebKit was open sourced in 2005. Chrome was once directly based on WebKit. Apple's Safari web browser is based on WebKit. iOS, Android, and BlackBerry all are or were based on WebKit. With the Phantom.js wrapper, we do things like allow you to override the IP for the host name of your target URL or specify what level of metric collection you want. Sensu spins up these headless agents. They go out, they pull the target website, return the metrics back through Sensu and often Graphite. So we dove in, continued forward with development. We maintained an internal Git repository until we were satisfied that we had molded the project into something tangible and not too horribly broken. Then on Friday, January 17th, 2014, we committed the code to a public repo. From that point forward, the public repo became our first class target for all future development. As we add features or squash bugs, the public repo is where we do that development work. So here's Joe to talk about some use cases within WebRocket.
Thanks, Mike. So with WebRocket, we pull our entire infrastructure. We have control sites out on all of our assets. And we use it to determine speed across our environment. Now, that's one use case, but I'm going to go over a different use case. So let's say you're doing some performance tuning for your web app, and you just want to know how fast am I making this as I make my changes. So a couple weeks ago when I was getting ready for this talk, I decided to set up a test website and run some experiments on it. So I ended up going with WordPress. It's pretty popular in the shared hosting business. I went with a typical LAMP stack and decided to use stock versions as my starting point. And the reason I did that is I needed a good place to start from and needed to make this thing go faster, so didn't want to optimize too early. So I went ahead and I pointed WebRocket at my test URL, and I'll get into the WebRocket UI in a little bit. So I decided to focus on time to first byte for a lot of these experiments, mainly because it's easy for me to control. Time to first byte's definitely not the most important thing you should be looking at, but it was easy to run tests against. So the first experiment I decided to do was I decided to enable compression for my CSS and JavaScript and text files and whatnot. And it actually hurt my time to first byte. Now, this wasn't too surprising because we have to take some extra time to compress all that stuff down before we send it across the wire. It's still a good thing to do anyways because I'm sending less bits, and so things should go faster, especially on slower networks. But it's good to know exactly what it did to my time to first byte on my application. So the next thing I did is I was using mod PHP to handle my PHP requests. Decided to switch that out and use fastCGI with PHP FPM. And it didn't really change the lower bounds of my graph. But what I did notice is it made things more stable. So PHP FPM has some obvious concurrency advantages. But when I was going for pure speed, it didn't really make it that much faster, but it did make it more stable. So if I would have done some before and after testing, I might not have caught that, hey, this has smoothed out my time to first byte quite a bit. So the next thing I did is I decided to install APC. I was running an older version of PHP, so that's the route I went. APC is an opcode cache for PHP. And what it does is it caches the bytecode so PHP doesn't have to compile source on every request. Definitely my biggest gain here, and it's recommended for anyone running PHP in a production environment. So, next thing I did was I decided to update all my software versions. Now I was running CentOS 6, which stock versions are pretty old, and there's been some improvements made. So I went ahead and bumped up from PHP 5.3 to 5.5. I switched from Apache 2.2 to 2.4. And instead of using fastCGI to hand off to FPM, I decided to use mod proxy FCGI. So again, just making these small little tweaks to my test application, I ended up gaining a little bit more out of it by just updating software versions. So what's the point? This was an easy tool to use to basically set up some consistent monitoring against my test site. I could sit there throughout the day and make small little tweaks to my test app, but I can see noticeable improvements as I went throughout the day. And I was able to use WebRocket to kind of query that data back and improve my results. So how does it work? I'm going to dive into how WebRocket does its thing. So when we started building this thing, we decided to use a monitoring framework as our basis. Started off with Sensu. It was extendable and definitely great application to use it. We pretty much use it for our scheduling and execution engine. And it was pretty easy to make it kind of do what we wanted to do with it. Also, it used a lot of the components that we would have used had we kind of rolled our own. The idea behind WebRocket is we wanted to reuse as much as we could and kind of just use what people have already written. We didn't want to get too worked up into rebuilding the wheel. So first thing we wanted to do was write the API. We wanted to open source WebRocket from the very beginning before we even wrote a line of code. So we decided to write an API. That way people could easily integrate with it. Now we know every environment's a little bit different. Some teams might be spinning up servers and tearing them down rather quickly. Some might have more of a static environment. And we wanted people to be able to call an API every time they added or removed a check or pullers or whatnot. So we ended up writing this in JRuby with Sinatra. And the reason we went that route is we didn't really want to get into the business of managing Ruby on your systems because we all know how much fun that is. So also we backed our API with a data source, React. We ended up going with React because we use it elsewhere and it works really well for us. All the WebRocket components talk to the API, so nothing actually talks to React directly except for the API, which means that you could easily replace this out with something else like MySQL, Postgres, Cassandra, whatever you want to use. The data structure is really simple and we don't store very much data. It's just little check objects. So next thing we needed to write was a check sync API. Basically we had our API, we had Sensu, so we needed to write a small little shim to basically grab our checks from our API and place them on the disk for Sensu to consume. The check sync API also handles restarting Sensu to pick up on the new checks. Now the reason we did this is we wanted to be able to use Sensu as is. We wanted this just to be a bolt-on component, and we didn't really want to modify Sensu to read directly from our API or try to maintain any forks or anything like that. Also, the check sync API is written in JRuby using Sinatra. So lastly, all of our metrics go in the Graphite. This was definitely big for us. We use Graphite all over the place at GoDaddy. And it's nice to allow people to use their own dashboards and their own user interfaces if they're already using Graphite without having to use ours. Also, if you're sending in system level metrics, it's nice to have your performance metrics for your website and your system metrics in the same data source. And you can kind of use those to explain your good or poor performance. So lastly, I'll go into the UI. I'm going to forego a live demo today because we all know how well those work out. So we wrote a nice little web UI using JRuby. This time we use Rails as our framework. So when you're getting started with WebRocket, you'll want to create a puller. We give you a default one built in, but you're going to want to scale out your checks or set up pullers in different locations. So we allow you to create different polling locations for your URLs. So in this case, I set up a few pullers, and it's nice you can set up pullers in the East Coast, West Coast, different networking segments, maybe inside your network. And you can time on how fast your application takes from all these different areas and compare the times. So the next thing we do with WebRocket is we create types. So we use types to organize our checks together. This is handy for if you're implementing this for multiple teams or product lines. It just helps you kind of nest your checks together into kind of logical groupings. And you can also add descriptions to your types and remove them from the UI as well. Now again, the UI is 100% API driven, so there's nothing extra in here. If you want to fly without the user interface that we provide, you just want to use WebRocket for the polling and scheduling and dumping data in the Graphite, have at it. So also, when you create a type, it basically creates a navbar menu at the top with a few things like creating and managing checks for that type, and then also presenting the data that is going into that type. So let's create a check. So when you're creating a check, you'll define what type you're going to use, and you'll also give your check a name. Now, in the check name, that's used when we're transferring data back into Graphite. So you can actually use periods in your name to nest your nest certain assets together within Graphite. Becomes handy. Also, you set your polar, you set your interval, your URL. You can also define an IP address when you're creating a check. This is handy for if you want to leave DNS load times out of your measurements, or if you just don't want to set up DNS for a simple control site. So also, we give you a page to manage your checks. We show you the check name, the interval, the polar that check's running on. But also the neat thing is we give you the command that the polar is actually running under Sensu. This helps if you're trying to debug a polar problem, or if you just want to run your checks manually without having to wait for the next scheduled pull or waiting for that data to make it back in the Graphite. So you can just run that on whatever polar server you want, and it'll dump the metrics right out on the command line. So let's get into some more graphs. I know you guys love graphs. So the first thing that we did was a simple list view. We did a 1 day, 2 day, 1 week, 1 month view. And it's meant to just be real simple and high level. The metrics shown here are the time to first byte, total time, and also the content length. Now that's important when you're setting up WebRocket, because you'll want to know how fast your site is going, but you also want to make sure that WebRocket's fetching your entire page. So let's say I have a site that's maybe a meg or 800K or something like that, and WebRocket's telling me it's only pulling 80K. That's definitely a problem, right? So I want to make sure that my tests are accurate and that they kind of represent someone actually running these tests from our web browser. So the next thing we did was we created a spot check view. So this uses cubism, and it's meant to be very high level. This data pulls out of Graphite on a regular interval, and so you don't have to refresh the page or anything like that. This is kind of a nice way to see all your data, because let's say you get a latency on a remote storage or a networking condition. You can easily see how that's impacting multiple assets within your type. So, and lastly, we created what we call the Graph Explorer view. So WebRocket collects almost 100 different metrics. And as I just showed you the other 2 displays, I only pulled out like 3. So this allows you to see all the other metrics that WebRocket is collecting for you, and you can visualize them. It also lets you define a fixed time frame or define your y-axis. So you can add multiple checks, multiple metric names. You don't need to know the names of those. So we have a nice little autocomplete in here. So basically once you start typing, it'll go out and it'll find the checks or the metric names that you're meaning to type. If it can't match on that pattern, it'll just display the entire list for you. So which is nice, because we have some really obscure metrics like when the DOM is ready and things like that. So you can get really nitty and gritty with your graphing if you want to. So Mike's going to talk about what's next with the WebRocket project.
Cool. Thank you, Jeff. So what does the future hold for WebRocket? So it's a pretty new project. It's less than 5 months old in development before it's ongoing. But we've got a couple ideas in our heads about where we want to take the project and what we can do with it. One of those things is virtualization. So it'd be kind of cool to take the polars or the Sensu threads that get spun up and wrap some lightweight containers around those. Or wrap, of course, a lightweight container over the whole Sensu thing, but then you've got much complexity added to your configuration there. Why would you do that? So say you're out on the street somewhere, right? You've got your cell phone and you've got like 1 bar on it. You're seeing a good 800 milliseconds of latency between your phone and the web server, somewhere between like 5 to 10% packet loss, right? Well, what does that look like for like a web page load? Or you're on DSL somewhere, you've got maybe a meg down and 50K up. What does that look like, right? So it'd be cool to add some wrapping around the polars, so that way we can do things like artificial latency injection and traffic shaping, and be able to actually measure what that's like over time. It also allows you to do things like apply tweaks to at the TCP level of your kernel and see, okay, cool, it makes this type of connection go really well, but this other type of connection makes it really crappier, right? Cool to see some of that kind of stuff. Dashboards. So right now we've got some basic visualization set up out of the box with our dashboards. It'd be really cool to add more numerical outputs, right? So given a time series for a URL, what is the, taking the standard distribution, what does the 3 sigma look like for that distribution? What does it look like when you apply changes to it? Some of the other talks today talked about different ways to detect anomalies, right? Etsy's Kale Suite is pretty awesome. We'd like to kind of tie some of those anomaly detections as well as trending data into our dashboard, as well as through the API, so folks can get at that data pretty easily. Alerting. So we're using Sensu, it's already there. It'd be fantastic to add ways to get alerting on particular bits when they happen, such as suddenly you encounter a 301 redirect on a page that didn't have one before. Maybe a human needs to know about that, right? Say that normally your page size is 500K and suddenly your page size drops down to 2K because IsoScriptix has hacked your website, right? Bad times there. There's different ways that we can go about alerting when things change, especially in the nature of serving up websites. We'd like to explore doing that, basically adding the alerting element. Dashboards. So out of the box, we're using Graphite. It works pretty well. There's a lot of really great dashboards out there in different areas that may or may not work with Graphite. It'd be cool to explore making sure that the way that we store and present data is accessible to those dashboards. Just something else we want to explore. And so we're primarily a Red Hat derivative shop. So we do Fedora, SunOS, and so of course our development started in those areas. Obviously those aren't the only operating systems out there. We'd like to go and make sure we've got packages for other operating systems. The installation works for other operating systems. Make sure all those bits are there. Also configuration management, super important, right? We are both a Puppet and a Chef shop. Thanks. So out of the box, some of those bits for some folks are no problem. We've got Chef, we've got Puppet. We can incorporate that stuff pretty easily. For other folks, not so much. It can be a real pain to try to bring your existing systems up to that level, right? And so knowing that, don't laugh. Our installation right now is a set of, what's the word, artisanal shell scripts, right? We did that because we didn't want that to be a barrier to entry, not because those guys are creating shell scripts, how dare they? We still want to go back and create, the Puppet, Chef, Ansible workbooks, all that kind of stuff. You haven't done it yet? It's on our roadmap, as it were. So, Joe again. Oh yeah, sorry. So, does this sound interesting at all? Sure, right? Yeah. So you might be asking, kind of, okay, cool. How do I find out more about this? How can I get involved, right? So, has anyone heard of Twitter, right? We have a Twitter thing set up. Just add WebRocket. Go ahead and follow what we're doing. I apologize, we're kind of terrible about the social media, but we're hoping to get a little bit better about putting updates out there. We've also got webrocket.io that has links to source code. It also has all of our packages, as well as like a quick start guide on how to just get up and going in just a few minutes. Well, provided you've got Graphite, but basically get you going out of the box. Plus also just some like high level ideas of what the heck we're doing with this and why we're doing it. So now here's Joe.
Yeah, thanks, Mike. So we're definitely humbled to be here, and excited for all the really good talks over the last couple of days. Also, a big thanks to Jason for bringing us all together. Really awesome. So what we're trying to say is thank you.